Hello, it's Mrs. Green, and this lesson is called Circumference and Area of Circles. So we have been doing shapes, area of shapes. We've done triangles, and we did quadrilaterals. And we did both perimeter and area of those shapes. Perimeter is something you already know how to calculate, so it was review. And area of certain shapes you know, and then we expanded that into some other more complicated shapes like trapezoids. And then we'll go even further with some complex shapes once we get the circles down. So we have a couple of formulas in my graphic. There's a formula for area. And I'll write the formula for circumference in a minute, just to remind you. So circumference for a circle is the same as perimeter of a different kind of shape. It's the distance around a circle. So I want you to write out your prior knowledge of area and circumference of circles. We have done a little bit of work with circles a few lessons ago. We did a general topic of circles with which identified a lot of the parts. You see some of the parts here with diameter and radius. And we had chord and we had different angles. There's so much information I had to break it up into two different lessons. One about the circle itself, and then this one goes into some calculations on how to figure out area and circumference. So let's do the key information on the next page. Okay, I want you to write the area of a circle. I'm going to have the formula for area of a circle and the circumference of a circle. I didn't write of a circle next to circumference because that word circumference only applies to a circle. So whenever you see that word, you know you are talking about a circle. So I'll go back up here to area of a circle. So the first piece of key information. This is key info. Area of a circle. So I'm going to write the word A for area and draw a picture of a circle. And I put a little dot in the center. Let's get that a little better in the center. So that you know it's not the letter O, it's a circle. So area of a circle equals a formula, which is the number pi. And pi you can estimate as 3.14 or 22/7. Either one of those numbers will work for pi. Some of you know a lot more numbers than just the 3 digits for pi, but that's the common, 3.14 is the common abbreviation for pi. So we've got pi, radius, which will use the letter R for radius. And you know that's the part of a circle that goes from the center to any edge. So it's halfway across the circle. That's radius. And then you have to square the radius. So you're going to multiply the radius by itself. The pi is not squared. The 2 is just applying to the r. It doesn't apply to the pi. So that's the formula for area of a circle. And then circumference of a circle is a little bit similar. It has some of the same elements. And we know diameter is the distance across a circle that goes through the middle. So it's a chord that goes from one end to another through the middle. That's d, which is equal to twice r, because if you go halfway across, that's r, and then if you go all the way across, that's 2r, which is the same as d, or diameter. And the formula for circumference of a circle is, I'm just going to write circumference equals pi times diameter, or 2, let's write circumference again, c equals 2 pi times radius. Or 2 radius times pi, whatever order. It's multiplication, which is commutative, so it can be in any order. Okay. Okay, example 1. Find the circumference. And the problem is going to be a circle with radius. I'm going to draw a radius from the center out. And that is 11 meters. I'm reading the book, so I have to look over my shoulder. Okay, so the circle that I've drawn has a radius of 11 meters. So I know that circumference equals, I like 2 pi r instead of pi d. If you want to use 2 pi d, that works as well. So 2 pi r, I'm going to substitute, so I need to check and see what I have r, that's my radius. Pi is a number, 2 is a number, so I don't need to substitute anything. But I'm going to leave pi sitting there for now. So 2 pi times radius, which is 11. I'm going to put parentheses in so you can tell where my pi stops and my 11 begins, and there's multiplication in between. Now I'm going to multiply these two numbers. I can do that in my head. 2 times 11 is 22. 22 times pi. And now it would be a good time to grab a calculator, or you can do some side work. So I've got 3.14, that's the number for pi, times 22. You can also do a fraction. You can do 22 times 22 over 1 times 22 over 7. That's the fractional part of pi. Either way. And once you do that calculation, once you do one of those calculations, you will get 69.08 meters squared. And so that's my the circumference, that's the distance. If I were to walk around the circle, it would take me 69 meters. Oh, it's not meters squared, I'm wrong. Get rid of this. This is green, it's not area, so it's just meters. I'm glad I did that, I figured it out. So if I walk around the circle, it's almost going to be 70 meters to walk around that circle. Okay, example 2. All right, in example 2 we have a word problem. So a Ferris wheel has, so we've got a circular Ferris wheel, and it's got the cars coming out. So you're hanging off the Ferris wheel. Hopefully you're not upside down. So these are the cars. This one's hanging like that. And they tell us that the circumference, the area around, the distance around the Ferris wheel, is 423.9, so almost 424 feet. They want us to calculate the diameter. And you might be thinking, well, I don't know the formula for diameter. And so they want the distance across, the diameter. Well, we can calculate that using the circumference formula. So for circumference equals pi d, or 2 pi radius. And since I'm trying to get diameter, I could use either one of these formulas, but I think I'm going to use the one that has diameter in it. So that's a little bit of a shortcut. You could use this one. So they've given me the circumference. So I know what C is. That is 423.9 feet. I'm not going to put the feet in when I'm doing the problem, only at the end will I put that in. So my C is that, 423.9. Pi is a number, which is 3.14. And I'll substitute that in a minute. And then D, which is the part we don't know. That's what we're trying to figure out. So that's going to remain your unknown. So let me go ahead and substitute the number 3.14 in for pi. Okay, so I have 3.14 times d. And I'm trying to solve for d. So this goes back to our knowledge of how to solve equations. I'm going to use inverse operations. So the operation that's happening here is multiplication. So I need to use division. So I'm going to write a fraction bar. And the number I want to divide both sides by is 3.14 because my goal is to turn this into a giant 1 so that my d is there by itself. So 3.14 on both sides. And when I do that math, when you divide 423.9 by 3.14, you can do some side work or you can grab a calculator. Make sure you're doing the division right. You're dividing the denominator into the numerator, or a long division looks like this over here. And you would get 135. And that's my diameter. So going across is 135 feet. And it's 400 and something feet around. And you're going to look for reasonableness. The circumference is about a little over 3 times, pi is a little over 3. A little over 3 times the diameter. So if the diameter is 135, if I do a quick check here, I get 400 feet, and that's not that far off of my circumference. So that's reasonable. Okay, example 3. Okay, example 3 asks you to find the area of a circle, and we're given a circle, and we're given the diameter. We can tell it's the diameter because it goes through the center, and it touches both sides. And they tell us that's 10 inches, and so they ask us to find the area. And area of a circle is area equals pi r squared. So I'm going to fill in the area I don't know, so that's the part that's going to stay a variable, a. Pi is a number, so I'm going to change that to 3.14. And radius I have to calculate because they didn't give me radius, they gave me diameter. So if my diameter is 10, my radius is 5. Most of us can do that math in our head, but you're simply dividing by 2 to get the radius halfway across the circle. So now that I have radius, I'm going to do that 5 squared. Remember, the square part only applies to the radius. Do not multiply pi yet. You have to, in order of operations tells you have to deal with the exponent first. So a lot of people make the mistake of doing the multiplication and then repeating the multiplication with the exponent. Don't do it that way. Do the exponent first. So 5 times 5 is 25. And then you can grab your calculator or do your side work. 3.14 times 25. And that's going to result in 78.5. So your area is 78.5 inches squared. So I did label it right this time. 78.5 inches squared, which is the area of my circle. So that's the amount of material it would take to cover my circle, my 10-inch circle. I call it a 10-inch circle because the diameter is 10 inches. All right, next. So this problem, example 4, says find the radius of a circle with area of 530 square feet. So they didn't draw a picture. If you want to draw a circle, you can. I'm going to use the area formula, which is area of a circle equals pi r squared. And I have to see what do I know and what do I not know. So do I know area? That's A. Yes, they gave me area. They told me it was 530 square feet. So I'm going to substitute 530 for the A. Do I know pi? Yes, I always know pi. It's 3.14. That's not a variable. That's a number. And then do I know radius? No. I'm supposed to find the radius. That's the piece that I'm solving for. So I'm going to leave the r. This is going to be a little difficult because I have a squared situation. It's kind of like the Pythagorean theorem. We'll have to unsquare it at the end because we're trying to find r. So my goal is to find r. I'm going to write myself a little note over here. That's my goal. My goal. So I filled in, and I just have one letter that's a variable, and so I should be able to use my inverse operations to solve. So again, I'm trying to isolate. When we solve for a variable, we're isolating r. And so I need to get a 1 in front of r. So I'm going to divide both sides by 3.14, both sides of my equation. That's going to give me a 1 in front of r squared, sorry. And then when I do the 530 divided by 3.14, 530 divided by 3.14, you should get 169.79. That's a good time to use a calculator. Equals r squared. And remember, I'm not trying to find r squared, I'm trying to find r. So you have to, some people might think you have to divide. And you're kind of dividing, but you're dividing by a very special number. You have to find the number. When you multiply that number by itself, it's going to get you 168.79. Now that's not a nice number. If it was 16 equals r squared, then that's a nice number. That's a perfect square. I can take the square root of both sides, and I can get 4 equals r. But that's not my situation. My situation is a little messier. I'm still going to do this step where I take the square root of both sides. So I'm going to take the square root of 168.79, and I'm going to take the square root of r squared. And anytime you take the square root of a square, they cancel out. So the root cancels with the 2. So you're going to get 168, square root of 168.79 equals r. And I would need a calculator for that. And I know that, actually I can do this one in my head. 169, I have that memorized. That's 13 times 13. You might have gone up that far. Probably most of you stop at 144, which is 12 times 12. So I recognize that this is almost 13, so r is about equal to 13. That's one way to do it. If it's very close to a perfect square, you can approximate, or you can use a calculator. All right, next example. Oh, I think that's it for the examples. Okay, one more example. I want to do an example like this because this is getting into real problem solving. All the stuff coming before this has been leading up to solving more of a real world problem. And that's finding the area of a composite figure. And what that means is we have these shapes. We have quadrilaterals, squares, rectangles. We have triangles. We have circles so far, trapezoids. And however, when you go to find the area of an actual thing in real life, many times it's not a perfect shape. And you might have to break it down into shapes that you know. So for example, if you had a building that had a couple of, maybe it's shaped like an H. So you have a wing here and a wing here, and then you have a bridge. There is no formula for calculate the area of a building that's shaped like the letter H. So you have to break that up into shapes you do know. So you'd have to make some lines and break it up into 3 rectangles, or you could break it up going this way into 2, 4, 5 rectangles, whatever makes sense. But you don't have formulas for a lot of these strange shapes. So this example, the composite figure, is a basketball free throw area, which starts out like a rectangle, and then it has a circle at the end. The top of the key is like a circle. Let's just do dotted lines. So, and I'm going to say that the top of the key is actually a semicircle. I should do that in a different color. Okay, let's do that in a different color. So the key goes like that. And then we have the middle of the circle. So you can see that, you might be able to see, if I wanted the area that I've outlined in red, the 2 shapes I have, there is no formula for find the area of the free throw area, that's in the red. But if you break it down, you can see there's a, do that in green. There's a rectangle right here. And there's a circle right here. So in my area that I want to find, there's a half of a circle and a whole rectangle. So those are the 2 shapes I do have formulas for. I don't have a formula for half of a circle, but if I calculate a whole circle, I can just divide by 2 and get half of a circle or a semicircle. And I do have a whole rectangle here. So I need base times height, and then I need the diameter or the radius of the circle. Those are the pieces of the dimensions that I need. So in my picture, I've got the height is 19, the base is 12, and the radius they give me of my key is 6. Those are all in feet. I don't know if these are accurate. They seem pretty accurate. Okay, so then we're wanting to find the area of the composite, so the piece that's outlined in red. So I'm going to calculate the 2 shapes. So the rectangle is going to be, area of a rectangle is base times height. In my case here, I've got 19 times 12. If you do that math, 19 times 12 is 228 feet. Then I'm going to calculate the circle. And then I'm going to turn it into a half circle. Let's do that in 2 steps. Some people might forget to do this step because they're so excited they got the circle. I wrote it here just to remind myself that I need to do 2 things. So circle area equals pi r squared. So area equals 3.14 times 6 squared. 6 is my radius. So area equals 3.14 times 36. If you do that on a calculator, you get 56.52 feet squared. But remember, that is my whole circle. That would be my whole circle. I only want half. So 56.52 divided by 2. Oh, I'm wrong. I looked at the book for my answer instead of grabbing a calculator. This has already been divided by 2. So 56.52 is the half circle area, because they have written in the book a 1/2. They did it in one step. They did 1/2 the area of the circle. So, let's see, somewhere back here, that means that this right here, my area, 36 times 3.14. Okay, so when you multiply 36 by 3.14, you get 113.04. Then you divide that by 2 and you get your 56.52. Now, the final step is to add those together. So I have to add the rectangle and the circle. So I have 228 plus 56.52. If I add those decimals, I get 284.52 square feet. Feet squared. That's the area of the composite figure. It's the shape of my key. So we're going to be practicing some composite figures, so I wanted to show that as an example. So now we have practice. Okay, your 5 practice problems. First, find the circumference of the circle, and so it's a 32-inch diameter of the circle. You're to find the circumference. Then we have 3 area problems. We've got find the area of a circle if the radius is 5 centimeters, or the radius is 28 inches, or the diameter is 3 kilometers. And then the last problem, then you need to find the radius of a circle when you're given the area. So the area is 50.24 feet. You need to kind of work the formula backwards to find the radius. And then you do your summary, and I will see you in the morning.